Okay, so we're going to look closely at the chain rule here. So oftentimes the chain rule is called the outside-inside rule because it's a composition, it works for a composition of functions. You have an inside function and you have an outside function. So in this case, f of x is the outside and g of x is the inside. So when you take the derivative of it, you take the derivative of the outside, keep the inside the same, and then you take the derivative of the inside function. Okay, so now we're going to look at an example here. And this example is going to have multiple steps to it. And you'll notice I like this example because it has a chain rule with inside of a chain rule, and multiple functions are being listed inside of others. So to start with, if we look at it, we see something's being raised to the third power. And then this is the cosine of 7x being raised to the second power. And then 7x is embedded inside cosine. So it looks like we're going to have 3 layers to this chain rule problem. All right, so we're going to start off using the power chain rule. So if I use the power chain rule, I'm going to bring the 3 out front. So that's going to give me 3 times 1 plus the cosine squared of 7x. And I want to drop that exponent to 1. Now I'm going to use a different color every time I take the derivative of the inside function. So now I'm going to take the derivative of the internal function, which is 1 plus cosine squared of 7x. Okay. And off to the side over here, you may want to think of cosine squared of 7x as the cosine of 7x to the second when we go to work with that. Okay, so this part's good. So we did take the derivative here. So this is the derivative. So I'm going to take 3 times 1 plus the cosine squared of 7x all to the second times. Okay, the derivative of 1 is just 0 plus, okay, now I'm going to take the derivative of this. So I'm going to use power chain rule again. So I'm going to put the 2 out front. It's going to give me 2 cosine of 7x to the first power. So I don't need to write anything else. And then I'm going to take the derivative of the internal function, which is going to be another color, which is going to be the derivative of the cosine of 7x. Okay, so let's see how this cleans up. So we got y prime equals 3 times 1 plus your cosine squared of 7x all squared times 2 cosine 7x times, okay, so now we got to take the derivative of cosine of 7x. Okay, so if I go to do the cosine of 7x, the derivative of cosine is negative sine of 7x. But then I need to take the derivative of the inside again. So I need to take the derivative of 7x. Okay, and I believe we're done doing the chain rule within the chain rule now. So now we can clean it up, because I can take the derivative of 7x at the end. So I'm left with 3 times 1 plus the cosine squared of 7x all squared times, I'm going to bring the negative 2 out front here. So negative 2 cosine 7x, sine of 7x, times, and the derivative of 7x is 7. Okay, so now I've got negative 14 times 3, which will give me negative 42 out front, times 1 plus the cosine squared of 7x squared, times, I already took the negative 14 out, so I'm left with cosine 7x sine of 7x. And that is your final answer. I'm going to leave you with this quote. So I'll let you read it for a second. So you can see how the chain rule, we had multiple layers, like an onion has multiple layers. But I like how they mention that if you take one layer at a time, and if it's too long, you start crying. So I think this is a great analogy. That chain rule problem only had 3 layers, but there was a lot to it.